Hello all, we are here for the lesson number 39 of this VariCAD training, and this lesson is called Geometric Constraints. So I will use very easy examples to show you the basics of constraining solids or elements. And for that, to start, I will build a very simple box. For example, something like this is a basic one, okay, and I will insert another box, for example like this. Okay, before I insert it, I want to talk you a little about what are the geometric constraints. Basically, the first two notions, and you can see here these two both icons that you can check also in the menu Edit, and you have the same two icons: geometric constraints among solid elements or among solids. So both of the options are very similar, so I will show you only one because the other one, this is among inside one solid, among the elements that compose solid, like holes, rib, box, whatever. This is the same but applied between solids when you are working on an assembly, so the concept is the same. You can use these two commands here, or you can go to the icon. It's the exact same thing. And when we are talking about the constraints, basically what we want to say, it is degrees of freedom. So when I insert a new solid in 3D space like the one I'm trying to insert, you have 6 degrees of freedom that every solid has available. So I can move it in terms of displacement for each one of the axes, clicking here, here or here, or I can rotate it around each one of the axes, this one, or this one. So 6 degrees. What we do when we work with constraints is remove degrees of freedom from a solid. So, for example, I will insert this solid. For example, I will insert it. It's overlapping the other one. And at this moment is a normal solid. If I do the translation and click this solid, you see that I can move it, okay, and if I accept, it will move. Or if I do a rotation, for example 45, and do the OK, it will rotate. So this solid normal, it has all the freedom available. Now if I try to constrain him, then it will have less freedom to move. So let us start to do something about this. So again, I will go back to my basic one. I will insert the same solid that I was playing. I will put it on another position like this. I will put it a little down to overlap a little this solid. And now when I try to insert, and I can do this, when I try to insert a new solid or element, or if I grab one of the existing one, I can apply the constraints. And for that, I can go in this icon here and said, okay, insert and add or insert and cut with the definition of constraints. I want to put add. So now I must define which one is the root solid, or which one is the solid that has no constraints, because this is a kind of a chain of constrained elements, one to the other, but you have to have one which is the basic, the root. Okay, so I will say this big one, and when I say this big one, I get this new toolbar with a lot of icons, not very complex, but let us try to see what we have here. And what we have regarding the constraints is around this toolbar. Basically, in this first area, you can see which are the degrees of freedom that were removed, and everything is great, so you don't have anything constrained. Okay, but I will apply a constraint now to this new solid regarding the root one, and I have a couple of possibilities. Starting here, I have a possibility to insert a distance on the x-axis regarding the insertion point of this big one. I don't want to do this in this case. I can do the same regarding a patch, and I will apply this one. And I can do locate it on a patch with intersection of an axis and a distance regarding a rotation axis. I will do this only for one of the axes. So regarding this one, I will say distance, and you see that the axis is highlighted at this moment, and I want to say that regarding this patch here, at this moment you see that it is placed on the patch. If I say now, for example, 20, and regarding directed or from, it will define positive or negative. Okay, saying this, and it will go a little on that direction and said okay, and now you have just one solid. This is the purpose of the constraints. What do I want with this? The first thing, it is the idea of the constraints, and you can work with this together with the parameters, is to have what we can call a clever or a smart object or assembly. And I'm saying smart because when you try to change, to make an addition of the shape or the solid or the assembly, when you do something like that, in theory, you can have everything updated more or less automatically. For sure, life is not perfect, and sometimes you may not get what you expect. But in the end and in theory, if you build your assembly or your part on a way that everything is constrained and properly constrained, then you can get this result. So I've placed this guy here. I can have a new one, for example. I will say at this moment again, add regarding this one. I've used this distance, in fact the y, use this distance. I could use this one, I don't want. I will use again this distance on the same axis, and now regarding this patch here, and let us put also 20 from this side, and we have an additional, besides this, I will click now and add, and what I can get now is, if I try to edit this solid on the dimensions, you see on this dimension, because they are constrained on this direction, okay, if I edit this dimension here, for example 120, what it happens, it is the model is updated, and because it was updated in this direction here, these remain equal, and the root solid change, and this is still respecting the constraint we've defined of 20 from this patch to the insertion point of this solid here. This is the basic of the constraints. Okay, so what do we have more here? We can have, for example, not this thing here. One of the things you can notice also, it is the cursor that in previous lesson for other reasons you saw that assumes different look regarding what you are trying to do, and in this case it's a basic nothing to edit. In this case you see the anchor. It shows that this is constrained somehow. Okay, you can check here also group of constrained objects, or you can say highlight on this scheme of links, okay, and say what is done or what is not done. Okay, so that you understand a little what is going on. Another thing we can do with this constraint, it is I can go and for example, let me try, I'm doing this wrong. For example, and you see that objects are affected by constraints, you have something down here, so you must be careful on what you are trying to do with this guy. I can move this, and you see when I try to edit this element only, the same window appears, and you see that in this area here, you see regarding the displacement, the Y, it is fixed, so you cannot move it. So you can move this a little around, for example. You can add a constraint for this point or not, but you can work around this, okay, but not this axis here. For example, let us try on this branch. Let us create a constraint, for example. Well, we can go first to displace it in this axis, do the OK, and you see that the movement was done because what is constrained is the Y. We can go, for example, and say, you can edit this and say, for example, 20. No problem also, because it does not affect the constraint itself. Okay, two things we can do. For example, if we try to work with a new box, for example, let us assume this corner here. I will put it a little down. It doesn't matter, it doesn't really matter the distance. I can go and say, for example, cut it to this root solid, and now I can go, still no constraints, and now I can go, for example, regarding the Z, I can say additional rotation axis, and I can say, for example, 20, and you saw that the solid was a little rotated but maintained the axis on the original orientation. So now I can say, for example, regarding this guy here, I can say, for example, for this patch it is 0, and I want to say not 30, I will put it okay, maybe it was on the other direction, sorry. Regarding this patch, 10, okay, like this. Very good, and do the OK. Now you saw that I'll try to edit this again. So edit this guy here, and let us say 140, and what happened, it is this moves because you have the constraint of the 20, and this moves because you have the constraint also to a face. So everything maintains. For example, if we try to edit only this branch here, we can go, we have this constraint also. This is on this direction and with an angle. So let us try to see what is possible. Display constraint links. We can have this, okay, but it's not this that I want to see. Here is, for example, okay. So you see also in this table that you have only the X, you don't have anything on terms of rotation. So I will say that I want to rotate. I can do several things, but for example, let us rotate here a little. Maybe it is better to use another example. Maybe I want to insert a new one, and for example, I will put it a little here and say add also regarding the big one. And now I want to rotate it. I want to rotate it, for example, this is the X, I can say 10, okay, for example, and say the okay, applied. And if I show this, you have anything, right? You don't have anything done because I've just applied an additional rotation. For example, I would like to apply, let me try to show you what I want. Not this one isn't the 3. This is not constraint, correct. So what I want is to edit this guy here. And before I show you what I want to talk a little about these guys down here. You have, besides these possibilities, we still did not see these ones, but you have these possibilities which are fix the location of this guy, okay. You can highlight or display what you have, and you can have, for example, if I click on this guy here, for example, and I can not like that, solid elements, okay. I can remove object from the group, or saying remove all objects from constraint group, okay, and now it is completely clear, okay. We can work a little, it is easy to have this grouped or not and remove one object or not, so I think it's not very complex. I will start a new drawing. I want to show you one or two additional things. For example, maintaining the same objects, these kind of objects, okay. One, I will insert a new one. For example, I will put it on another color just to see better what we are doing. Doesn't matter the place where we are. And regarding these two elements, I will say I want to constrain this guy here regarding this one. So I will apply an additional rotation on this Z, and we'll say, for example, 15 degrees, and do the OK. And now if you try to edit this guy here. I did not put a distance. I could put a distance, in fact. I could put a distance and I did not put it, but okay, it doesn't matter. If I want to rotate this guy, for example, 15 degrees more, it is still possible. But if I come down, okay, here and say constraint these elements, these regarding additional rotation 15, and put a distance, for example, regarding the y, and this face here we have 23, you can do it, no problem, and do the OK. Now if I move it, I will say to this guy, go down here, the one goes with him. Or if I say this guy, let's try to move it a little, 10 minus, let's see if the other goes, no, in this case it was not behind him, something it is not so perfect in terms of the constraints. Okay, I want to show you a couple more things in terms of inserting new objects. For example, I want to insert and add regarding this one here, and I have a couple of options also here which are important. First one, it is location at patch, and if I say the patch, okay, you must see I've done the intersection with X against normal, so you must see the position of the first solid that was, if nothing changed according to the coordinate system of the program. Or in this case I must go back, otherwise it will make a complex thing. For example, regarding this one, this is the same. I don't have circle center, so that this one I must put a hole or something to show you. But we can use also, for example, against a plane normal, which is the X. If I say this, the X will be faced to this, I don't want, so if I click this one, this will rotate, okay? It will face the plane. Or if I do this, now it has problems because with the previous click I've done already a constraint on the movement, so you have to deal a little about this. For example, if I try to create a new one again and place a hole, let me try a hole or putting something diameter, let's put this a little smaller, for example 90, and putting this more to the center and saying again add for the big one, and now I could say not this, but I want regarding this green, the Z, I want to say Z-axis distance from a rotation axis. I don't have one, so I will just say for a patch which is this, let's say for example 20, and do the add. If I try now to add a new one again, I can say now add it regarding the green solid, and now I want to say for the Z I want in fact regarding a rotation surface which can be this, and I can align this guy with one of these axes, and I can say, for example, the y, and the y directed to the axis. What is the distance? I can say, for example, 10, and what it does, it will move my cylinder to this direction. Okay, I can come back because maybe it was not so clear. So let us try now, instead of the y, the z. So the z, again, I will say my rotation surface, this one, and I want to align it now with the y again, and now I'll go along the rotation axis and say, no, not 10, just 5, and say on the other direction. Okay, and do the OK, it will insert it. Again, the idea of this is going to this, do the addition. If I go on this one, for example, 40, was not the right one because it will go to the other direction. Okay, it will change because it was in the middle. We are playing with this only with the constraints, but we can mix the concept and saying constraints and parameters, because when we are saying insert something, give these directions, saying okay, do this, for example, and do the add and put a constraint regarding this solid. When we are saying, for example, consider this distance, for example, the x regarding this patch here, for example, we can have the possibility to put a parameter. Okay, we don't have a parameter at this point, but for example, let us say that we assume the 41 and do the OK. If we go to the parameters now, insert a new one, it can be an angle or a linear, but let us say, for example, A, and this will be 30, create a new one, insert it, and I want a new, which is the B, and I say 25, create and insert it. Okay, when I do this kind of thing here, again, insert and now cut, just to be a little different for this solid, and I want this axis here to be distance from this face. It can be a parameter that is the A. So OK and OK. So you see, it is done. Now if I want to edit, not this, but and not for sure not this one here, but for example, if I want, where can I see the tree? This one has no tree of events, so this is from the solid itself. Okay, this one here. If I edit this guy here, you see this is defined as the A30. I can go, it is identified. I can delete it, but I can say where it is. Sorry, I don't want this boolean tree editing. Sorry, I can edit it. I was on a strange position. We can go and okay, finish, not this, sorry, just a little, making a mistake. Branch, sorry, it was my mistake. Branch and do the cutting. Dispatch, I don't want this, I want the 25. Okay, test problems. I cannot put a new one. I can this is why it is important to say that we cannot add. This is the addition of the new one, and clicking and editing, not what I was doing. It was important to understand also. So do the addition, so it will go a little inside and making a new one. So maybe it was a little confusing. Let us try to do this again. This area here, do the OK when the parameter, not this one, sorry, this branch, sorry, this area here, do the OK, and when I got this thing, I can do the addition in this icon here. Okay, addition, and then if you click with the right mouse button, you can delete it, highlight, or edit the constraint. You have also the icon available when you try to make this the branch. You see that the icon is available also here, so you can go to this schematic and say, okay, this guy is here, so you can do whatever you want with him. Okay, so I'm not sure if this was completely clear about the constraints. This is a little difficult to explain all the options, all the notions of the constraints. If you have some problems, or if you have some examples where you need help, you can send us. We can try to get you a solution to constrain your models, your assemblies. But anyway, I hope that the basic idea of this, it is clear, which is we want to remove degrees of freedom when we insert things in 3D space. We want to connect this, if possible, to parameters to bring automatic updating on the addition and on the changes we need to make to the assemblies or to the parts. And this will introduce us a little on what we can call smart or clever objects. Okay. On the next lesson, we will complement this information with the addition and the parameterization of the 2D profiles, which in some objects will not, that in some objects are the birth of the solids. So everything complemented. There is no magic formula, but you need to see what it is important and how to work properly with your models. Okay, so I hope to see you in our next lesson.